Good afternoon, everyone. Thanks for joining us here at Caltech in the astronomy department for a super fun presentation and cartooning event. I'm Dr. Cameron Hummels. I'm a researcher here, and I just have a couple of short, brief announcements before I introduce our speaker, the reason you all have come. If this is your first time here, we actually have a lot of public events that take place in this department, as well as telescopes on the field behind here. Once a month, we have a free public lecture that is appropriate for families and children as well, on some different scientific topic, whether it's black holes or the evolution of galaxies or stars or planets around other stars. And then that's 30 minutes. And then afterwards, we set up telescopes on the fields directly behind this building, and you can see various different things in the sky, some of the topics that maybe even covered in a book like this. And so that happens once a month on a Friday night. Our next one is this Friday night, talking about building a telescope on the far side of the moon, which should be super cool. It'll be at 8 o'clock. And like all of our events, this event is being live streamed on YouTube, so you can go check it out on our YouTube channel later today if you missed something during the presentation, or we have recordings of all of our previous events on there as well. And I would be remiss if I didn't mention there's going to be a really cool event in about 3 weeks. There's going to be a solar eclipse, a partial solar eclipse that will be visible from here at campus, and we're going to have an event. It'll happen on a Monday morning, Monday, October 14th. You can come. It'll happen at about 9:30 a.m., but we'll be set up for an hour or two that morning. Maybe your schools will have events going on as well, but we'll have telescopes set up that you can safely look at the sun and see the moon passing in front of the sun. And we'll also have eclipse glasses that we're handing out so you safely can look at those events as well. So I don't know what school regulations are on missing an hour of school to come to an astronomy education event are, but perhaps consider it. We're probably going to be set up from about 8 a.m. to 11 a.m., but the actual eclipse where the moon is most covering the sun, it won't totally cover it. It won't get dark during the daytime like a total solar eclipse, but that'll happen at about 9:20 a.m. Okay, those are most of my announcements. Thank you all for joining us. I am really honored to introduce our speaker. Our speaker hails originally from Panama, where he was born and raised before he did his undergraduate studies at Georgia Tech. And then he did his PhD in robotics and mechanical engineering at Stanford, just a few hours north of us in Northern California. After that, he came here. He was a member of the Caltech staff. He was both a scientist as well as an instructor, teaching students all about robotics and mechanical engineering. And then after that, he basically focused hardcore on cartooning, and probably what you know him best about, the PhD Comics franchise that he is award-winning, best-selling, is available in many different languages in countries around the world. You should check it out if you haven't. It's very entertaining and has a lot of the facts and comedic parts of living in academia and working in science. I know I laughed a lot about it growing up. So, and more recently, he co-authored a book called We Have No Idea, about some of the unsolved questions in physics. He is the co-creator of a PBS Kids program called Eleanor Wonders Why. And now he has a new book coming out called Oliver's Great Big Universe. And he's going to talk about that tonight and do some cool cartooning exercises. So please welcome Dr. Jorge Cham.
Hello, welcome to Caltech. Now, first of all, I want to thank Caltech and the astronomy department, and especially Dr. Cameron Hummel for organizing this and all the amazing outreach that he does. Let's give him a big round of applause, please. Awesome, and a couple of professors here also are a big part of the story as well. a big shout out to you as well. Now, I have a question for all the kids here in the room. Are you ready for the question? Okay. The question is, do you want to know a secret? Now, okay, hold on. A secret is a big responsibility. Are you sure you want to know this secret? All right. Yes. Very eager. Okay. Now I'm going to need all of the adults in the room to close your eyes and cover your ears because this is only for the kids. All right. You're all covered. All right. Okay. Here's the secret, everybody. Are you ready for the secret? The secret is that the universe. Do you know what the universe is? Yeah, it's everything that we can see and everything that we know about. That's the universe. The universe is like a giant fart. It's like a giant fart. Okay, now I'm gonna take it out, and then now the adults can uncover their ears and open your eyes. Okay, now I'm gonna explain that to all of you, but first I should tell you who I am. I know they mentioned that my name is Dr. Jorge Cham, but you can just call me Mr. Jorge. And I studied for a long time to be an engineer, and I worked on making robots for science, and I did that for a long time. And then one day, I decided to be a cartoonist and draw things like comics and cartoons. And mostly I write books with cartoons in them about science and cool things about science. And so that's who I am. And so I wrote this book called Oliver's Great Big Universe, which I'm going to talk about today. Now, this book, it's about a character. Can you guess what the character's name is? Oliver, obviously. His name is Oliver, and Oliver is a pretty typical 11-year-old kid. He's a pretty normal kid. He has 3 favorite things in the world that he likes to do. Okay, so the first favorite thing that he likes to do is he likes to read. He likes to read books. He likes to read comic books. That's his first favorite thing in the world to do. His second favorite thing in the world to do is that he likes to play video games. Yeah, I can tell a lot of you like to play video games. Now, can you guess what his third favorite thing in the world to do is? TV. That's a very good guess. Eat, yeah. A lot of people say pizza is his third favorite thing in the world. Actually, his third favorite thing in the world to do is he likes to play more video games. That sounds more like an Oliver that you might know. Okay, so in the book, Oliver one day meets someone called Dr. Howard. Dr. Howard. And after meeting Dr. Howard, Oliver decides that he wants to be an astrophysicist when he grows up. An astrophysicist. Now, if you've never heard that word, that means that's someone who studies things out there in space. So astro means stars, physics means how things work. So astrophysicist is someone who studies stuff in space and how they work. The only problem is that Oliver doesn't really know what an astrophysicist is or doesn't know much about the universe. And so he decides to write a book about the universe. And so that's the book that you'll be reading if you get it here today, called Oliver's Great Big Universe. Now, in the book, Oliver tells all kinds of funny stories about things that happened to him at school, at his house with his little sister, on a road trip with his family. And so I'm going to tell you today one of the stories that he talks about in the book about something that happened one day in the cafeteria. I know all the kids are going, uh-oh. Now I'm gonna try to do something kind of fun, which is that it's gonna be the story about Oliver, but I'm gonna try to maybe include one of you in the story. Now I need a volunteer to be in the story with Oliver. So who would like to volunteer to be in the story? Now, are you sure? Because you don't know what's gonna happen in this story. Okay, we'll go with you right there. What's your name? Callie. Yes. No, you can stay where you are. Okay, so I'm going to try to draw you into the story. Okay? All right. Let's see. And is he wearing a t-shirt? You're wearing jeans. Okay, and now what's on your t-shirt? It looks like what is that symbol of? It's a symbol for astronomy. Oh, I think we got a ringer here today. Okay. What just happened? Okay. Okay, so Oliver and Cal, right? Oliver and Cal, I know I've met you before. Oliver and Cal were in the cafeteria one day, and they were very excited about this special day because they were serving potato tots at the cafeteria. Tater tots. They were serving potato tots, and they were very excited about it. But there was one problem, which is that there was one kid at the head of the line who was asking a lot of questions about the potato tots. A lot of questions, and he was holding up the entire line and wouldn't let anyone get their potato tots. And so more and more kids started to walk into the cafeteria, and it started to get more and more crowded. But he kept asking questions, and so then more kids started to pile into the cafeteria, and it started to get really crowded and squished together. So Oliver started sweating a little bit. Cal started to sweat a little bit. All these kids started to crowd more and more into the cafeteria. All the kids were getting really cramped together. They were really squished together, started to get really hot to the point where kids started to demand their potato tots. I want my potato tots! And then somebody uttered those four fateful words you never want to hear in a crowded cafeteria. Did someone just fart? Did someone just fart? Now, what do you think happened next? The whole place exploded. Kids started running as fast as they could in all directions, trying to get away there as fast as they could in every direction. They were all really squished together, really hot, and then they went flying in all directions. Now, I want you to keep this picture in your mind. Think about what was happening right here, because this is how the universe started. Yeah. That's how the universe started, kind of like a fart in a crowded cafeteria. So a long time ago, 14 billion years ago, everything that you see in the universe right now, all the stars and all the planets and all the galaxies that are out there, a long time ago, it all used to be really squished together into a space smaller than this little dot. It actually should be smaller, but if I drew it smaller, you wouldn't be able to see it. So all the stuff in the universe is really crammed together into a space that small. Everything was super duper hot. And then one day, it exploded. Boom. It exploded into the universe that we see today. It's called the Big Bang. So everything got really big. Yeah, you maybe have heard of it. The Big Bang. Everything got really big, really fast. Now, I have another question for all of you. This is a big question. This might be the biggest question anyone has ever asked you. Are you ready? Luna, you ready? Okay, is everybody ready? Okay, the biggest question you've ever been asked is, how big is the universe? How big is the universe? Well, let's find out. We're going to explore this question. And so I'm going to need another volunteer to go on a little space trip across the universe. Now, again, you gotta think about this carefully because you don't know what's going to happen. Are you sure you want to volunteer? Okay, we're going to go. We're going to go with Natalia. Are you sure you want to volunteer for this? Okay, I'm going to draw you into the story then. What did I do? Here we go. Okay. All right. Let's see. Now, Natalia, are you you're an astronaut in this story? Now, are you like a serious astronaut or are you like a happy astronaut? You're a happy astronaut. All right. We'll see what happens. You're a happy astronaut, and I'm going to draw you. Oh, what's going on? Oh, can I still draw? Okay. I'm going to draw you in a side of a spaceship. Oh, what's going on? Oh. Okay. Oh. Oh. I'm not sure I can. Yeah, maybe. Thank you. Okay, maybe that did it. Did I not? Okay, what's up? Sorry, technical difficulties. Oh, it suddenly stopped. Okay, well, we'll make it work here. We'll just make this a really flat spaceship like this. Okay, now Natalia, this is your spaceship. You're an astronaut. What is the name of your spaceship? The USS Sparkle Trip. Okay, USS Sparkle Ship. Okay, USS Sparkle Ship. And the other question I have to ask you is, how fast does your spaceship go? Now, before you answer, I should tell you that when you're in the car with your parents and you're going down the highway really, really fast, you're probably going around 100 kilometers per hour. Or at least that's how fast your parents are supposed to be going. But you're going down the highway really fast, you're going 100 kilometers per hour, which is pretty fast. Now, how fast does your spaceship go? Like 200 kilometers per hour? More. Oh boy, like 1,000 kilometers per hour? Okay, are you sure? 1,000 kilometers per hour? What do you guys think? Should it go faster? Faster, all right. How about 10,000 kilometers per hour? Faster? Are you sure? I'm getting a little nervous for Natalia here. 100,000 kilometers per hour? Faster! How about 1,000,000 kilometers per hour? 1,000,000 kilometers per hour? I'm not sure we should go that much faster. So I'm gonna say a million kilometers per hour. Okay, that's how fast Natalia is going across the universe. That's how fast Natalia's going. Now let's see. Now let's talk about how big the universe is. And let's start with the planet Earth. So the planet Earth is, how wide it is 12,756 kilometers wide. That's pretty big. If you were to plot where we are here in Los Angeles, it'd just be this tiny little dot here. That's how big the Earth is, 12,756 kilometers wide. Now the question is, if Natalia is on a spaceship here, and she were to go all the way around the Earth and back, how long would it take Natalia to go all the way around the world if the world is 12,756 kilometers and she's going at 1,000,000 kilometers per hour? Okay, so well, hold on, let me do the calculation. Give me, you have to be a little quiet. Give me a second here. 12,756 kilometers divided by 1,000,000 kilometers per hour. Convert that to seconds, minutes. Okay, it would take her 2.5 minutes to go all the way around the Earth. I know that's a long time for little kids, right? If your parents tell you, hey, can you wait 2 minutes? That's like forever. But even though she's going at 1,000,000 kilometers per hour, it would still take her 2.5 minutes to go all the way around the Earth. Now, as you know, you might know, the Earth is not the biggest thing around. The Earth is actually pretty small if you compare it to the sun. If I were to draw the Earth right next to the sun, it would look a little bit something like this. That's how big the sun is. And in fact, the sun, if you measure how wide it is 1,400,000 kilometers wide. 1,400,000 kilometers wide. Now, if Natalia was here on her spaceship, how long would it take her to go all the way around the sun and back? Let me see if I can calculate this. 1,400,000 kilometers divided by 1,000,000 kilometers per hour. It would take her 11 minutes to go all the way around the sun. 11 minutes. That's, even though she's going at 1,000,000 kilometers per hour, it would still take her 11 minutes to go all the way around the sun. That's how big the sun is. And so the sun is pretty big, but there's actually bigger stars that we know about. So the biggest star that scientists know about is called UY Scuti. I know it's a super funny name. Like if it ever asked you to scooty over, you would have to move a lot because it's a giant star. Okay, UY Scuti is how wide it is. 2,300,000,000 miles wide. 2,300,000,000 miles wide. If you were to draw our sun next to UY Scuti, it would look something like that. That's how big the biggest star that we know about is. If you were to draw Earth, you wouldn't even see it. It would be a dot so small you couldn't even see it on this screen. So that's how big UY Scuti. Now, if Natalia were to get on her spaceship and try to go around UY Scuti, going at 1,000,000 kilometers per hour, how long would it take her to go all the way around? 10 hours, you think? Whew. Years, maybe? Let me do the calculation. 2,300,000,000 kilometers divided by 1,000,000 kilometers per hour. It would take Natalia 8 months traveling in her spaceship, going at 1,000,000 kilometers per hour. Can you imagine what it'd be like to be in a car with your parents for 8 months? That would be a really long time. Okay. UY Scuti is the biggest star that we know about, but actually there are even bigger things in the universe. Even bigger things in the universe. So our sun, UY Scuti, they're stars, but they're only 2 of the 100 million stars that are in the Milky Way galaxy. So if you were to draw just one of those dots, that's our sun. There's 100 million, right? I think, right? 100 million. 100 billion, sorry, 100 billion. I'm glad we have experts here in the room. 100 billion stars in the Milky Way galaxy. So if you were to measure how wide the Milky Way galaxy is from one end to the other, you would measure that the Milky Way is 1 quintillion kilometers wide. That's a 1 followed by 18 zeros. Now, I'm pretty sure it's going to take Natalia more than 8 months to go all the way across the Milky Way. So I'm going to let Natalia change the speed of her spaceship. Natalia, we can make it make your spaceship go faster. How fast should we make your spaceship go? 1 bazillion. What? Meters per year? Kilometers per hour? The speed of light. Whoa, 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 whoa. The speed of light. Faster than the speed of light. Okay, okay, okay. Okay, everybody. Hold on, hold on. Yes. Okay, I'll explain it for everybody else. Yeah, well, yeah, I know you want to go faster, but let me explain something about the universe. Okay, shh. Okay. It turns out that the universe has a speed limit. Kind of like the highway here that has a speed limit. The universe has a speed limit, and it's called the speed of light. That's the fastest anything can go in the universe is as fast as light can go, and it is. Now I'm really nervous because I know there are astrophysicists here. It's 300,000 kilometers per second, right? The speed of light, at least that's what I've been saying all this time. 300,000 kilometers, not per hour, per second. That's how fast light can go. If you shoot a laser here on Earth and had it go around the Earth, it could go around the Earth 7 times in 1 second. That's how fast light can go. Now, we're letting Natalia go at the speed of light. I know, yeah, I know. It's a long time to be in a spaceship. Okay, we're letting Natalia go at 300,000 kilometers per second. How long would it take her to go from one side of the Milky Way to the other? I'm going to do the calculation. 1 quintillion kilometers divided by 300,000 kilometers per second. It would take her 100,000 years to go from one end of the Milky Way to the other. Now, do you think Natalia packed enough food to bring on her trip? No, for sure not. Yeah, she would have to pack a lot of pizzas, wouldn't she? Okay, yes. All right, now it turns out the Milky Way is not the biggest thing in the universe. There are even bigger things. There are even bigger things. For example, there is the Laniakea supercluster in the Guys, I've been talking too much. All right. In the Laniakea supercluster, there are 100,000 galaxies, kind of like the Milky Way galaxy. Each one of these dots is a galaxy. Now, how wide is this supercluster? This supercluster is 5 sextillion kilometers wide. 5 sextillion, that's a 5 followed by 21 zeros. 5 sextillion. Now, how long would it take Natalia to go from one end of the supercluster to the other? 5 sextillion kilometers divided by 300,000 kilometers per second. It would take her a million. You were saying a million? It would take her 500 million years to go from one end to the other side. Actually, you won't be that, and I'll tell you why at the end of this part here. Okay, so it turns out the supercluster, Laniakea super, is not the biggest thing in the universe. There is something bigger, which is basically all of the universe that we can see. So scientists think that there are about 10 million superclusters like the Laniakea supercluster in what's called the observable universe, which is as far as we can see in the universe. Now, how wide is the observable universe? The observable universe is 900 sextillion kilometers. It's a 9 followed by 23 zeros. I'm pretty sure. I'll check on that. All right, that's how wide it is. Now, how long would it take Natalia to go from one end of the observable universe to the other side? 900 sextillion divided by 300,000. 500 quadrillion. It actually would take her 90 billion years to go from one side of the known universe to the other side of the known universe. Would she already be super old? Not necessarily. So there's something really interesting about the universe, which is that if you're moving really, really fast, almost at the speed of light, then time will move really slow for you. So if you were to look at Natalia going at almost the speed of light across the universe, she would look like she's moving really slow. So even though it took her 90 billion years to us to go to one end of the galaxy universe and then 90 billion years to come back, she might not age much at all if she's going fast enough. Now the problem is though that everybody else that she knows will be 180 billion years old, and she might be about the same. So that is basically how big the universe is. Now I said it's as far as we can see, because that's about as far as we can see of the universe. The universe is so big, there are parts of it that we still haven't been able to see, and that we may never see. Because I want to tell you two things that are pretty cool about the universe. Two things that are pretty cool about the universe. The first one is that the universe might be even bigger than that. So that's just as far as we can see. It could be that the universe just kind of ends after 900 sextillion kilometers, or the universe might be much bigger. In fact, it might go on forever. The universe might be infinite, in which case there might be an infinite number of planets out there, and which means there would be an infinite number of aliens out there as well, which is pretty cool. Now, the second thing you should know about the universe is that the universe is still exploding. The universe is still exploding. It's still getting bigger and bigger and bigger every day, every second. The universe is getting bigger. It's not getting as big as it did when the universe first exploded. That was at the Big Bang, but the universe is still growing. It's still expanding. It's getting bigger and bigger. And it's growing, kind of like you guys are still growing. I know it's shocking. It is shocking how big the universe is. All right, so that's how big the universe is. And so there's a whole chapter in Oliver's book that talks about how big the universe is. And there are other chapters that are really interesting and cool, like what it's like to be out there in space. There's a whole chapter where Oliver talks about black holes. You never want to fall into a black hole. And there are chapters also about the planets in our solar systems and how they're all different. So I hope you get to check out the book. They're selling outside if you can find it at a local library or something. But please check it out and learn about all this really cool stuff. And also a lot of fart jokes and poop jokes. And so I just want to say that this whole book was inspired by my son. Can you guess what his name is? It's Oliver. Oh, Oliver's his curiosity, how smart he is, how funny, inspired the book. He's a little bit more grown up now. He has long hair. So and he's a teenager. Ooh, now, so he's growing and changing a little bit. But that's where the idea for the book came from. And so that's my presentation here today. Thank you. Awesome. Thanks for being here. I'll take questions. Does anyone have any questions? All right. Yes. I'm a little scared because you seem to know more about the universe than me.
Can we get our book signed?
Absolutely, you can get your book signed. I'd love, and I'll even draw a doodle for you. How about that? Yeah. Any other questions? Yeah. Yeah, how did I start cartooning and doodling is the question. I started when I was really young, about the age of these kids here. I would read a lot of comic books and comic strip collections. That I grew up in Panama, and my parents worked for the Panama Canal. And so they would often drive through the American bases, and they would stop at garage sales that American families were having before they went back to the United States. And so sometimes they would be selling huge boxes of comic books and comic strip collections. And so my dad would just buy these and bring them home, and my brother and I would just read them. And that's actually a big part of how I learned English. But that got me really interested in comics and comic books. I've been reading them all my life, and that got me interested in drawing and doodling. I would do that a lot in my notebooks. I'm sure a lot of kids here today, you draw in your notebooks, and that's how it all started. Okay, Demi. How old is Oliver? 14 billion years old. Oliver, in the book, he's 11, but the real Oliver is now 13. He's a teenager. Yeah, in the back. Can you repeat the question with the microphone?
So if the black, if a black hole, sciencey stuff like that, that would.
One more time. Start over. Okay, sorry. Go ahead.
If a black hole and sciencey stuff like that, would crush anything that goes in it, wouldn't it crush everything else too?
The question is, if things get crushed when they fall into a black hole, what happens if everything falls into a black hole? Is that your question? No, not quite. Sorry.
If the black hole sucks stuff in, wouldn't it suck everything in?
Interesting question. So a black hole is like a hole in space. And it's a kind of a weird kind of hole because it's like a hole in space. So like if you, if this table had a hole, it would look like a hole when you look at it this way. But if you look at it from the side, it wouldn't really look like a hole. It would just look flat. But a black hole in space would look like a hole no matter which direction you look at it. Like if you look at it from the top, from the bottom, from the side, it just looks like a black hole. And black holes suck stuff in because they're so dense and they have a lot of gravity, and stuff would fall into them. And the question that you asked was, is a black hole going to basically swallow the entire universe, right? Is that kind of what you want to know? Whether you have time to watch more TV or play video games before the black hole sucks us all in. Well, the thing about black holes, they do suck a lot of stuff in. A lot of the stuff falls into the black hole, but not everything falls into a black hole. Sometimes things are so far apart, or they're moving away from the black hole so far that they're not actually going to fall into the black hole. For example, like if you take the sun here in our solar system and you squish it down a lot, eventually it's going to become a black hole. But we won't automatically fall into it. The planets are just going to keep orbiting around it. It's just, a black hole is really just a really dense object. So I think you're okay. Yes. If you went inside the black hole, would it still look black? Well, there's a lot of interesting things about a black hole. I could probably, I could spend an hour talking about black holes. I'm sure there are people here who could spend even longer talking about black holes. But it's really weird when you go close to a black hole. As you get closer to the black hole, light starts to get bent really weird around a black hole. So black hole will actually start to kind of get bigger and bigger the closer you get to it, and it actually look like it's all around you. Eventually, the whole universe is going to look like just a little tiny point of light behind you as you go into the black hole. And that's all you're going to be able to see inside the black hole if you survive going into the black hole. Okay, Natalia.
How did you get the idea of using your kids for your...
Yeah, how did I get the idea to use my kids for a TV show or a book about the universe? That's a great question. I hope that's a good idea. I've left some money for their future therapy sessions in my savings account. But no, how did I get the idea? You know, for me, when I make art, when I write things, it's really important for me to write about things that I know and things that I feel really close to and that I'm really familiar with and I feel passionate about. And so for me, it's just a lot more fun to make characters based on people that I know. First of all, it's a lot easier to make up characters based on people that you know. And for me, it was just, you know, I wanted to capture how awesome and how fun and how funny my kids were. And so that's why I based characters on them. Yeah, in the back, the gentleman in the back, yes. Yeah, that's a great question. So the way a black hole looks like, it looks like a giant black sphere, like a ball, okay? And the blackness of it is called the event horizon, or it's approximately the event horizon of the black hole. Now, if you go past that point, if you go into the black stuff, then you're definitely never getting out because not even light can get out of that. Even if you shoot a laser, if you're inside and you shoot a laser, try to shoot a laser out of it, it's not gonna go out. It's just it's gonna get stuck inside the black hole. So if you definitely go into the black part of the black hole, then you're definitely stuck. If you haven't gone in there, most likely you would still die. Because when you're close to a black hole, there's so much gravity that it would actually sort of shred you apart. It would stretch you out and you wouldn't survive. That's actually how we can see black holes, is that the stuff that's about to get sucked in, that's circling, waiting, kind of like a toilet before it flushes down the middle. That stuff is getting shredded and it's going so fast that it glows. And so that's how people can see black holes. But it also depends on the size of the black hole. So if the black hole is big enough, you can actually get kind of close to it because it's so big. The gravity is not so crazy. But the smaller black holes are actually a little bit more dangerous if you get close to them. Yeah. Yes, Luna. How do you get the videos of what? People going into black holes? That might be YouTube magic. Yeah, no. So nobody has ever actually been to a black hole. They're really, really far away. The closest one that we know about, I think it's the one at the center of our galaxy, right? That's the closest one, and that's about 50,000. It would take you 50,000 years just to get there, going at the speed of light. About. So it's really far away. Nobody has ever been close to one. We can just kind of see them from far away. Yes. Why does the galaxy look like a swirl? Wow, these are really hard questions, and I'm totally intimidated here in the astrophysics building. I think I have an answer, but maybe Cameron, you might have an answer as well. It looks like a swirl because when it used to be the galaxy was just a big cloud of gas, rocks, and stuff, and when it started to get scrunched together by gravity, things were kind of spinning, and so everything was spinning. And so kind of like our solar system, all the planets are spinning around the sun. The same thing kind of happened to a galaxy. All the stars in the galaxy start spinning like a disk. And then after that, there's more complicated things that make it look like a swirl, right?
There's some more complicated things, but that's the gist of it. And the comparison that a lot of people like to make, you think about figure skaters. Remember the figure skaters, they start spinning slowly with their arms really wide, but then what happens? They pull their arms together and they start spinning really fast. It's the same thing with these, the things that start out that eventually form into the galaxies are usually much puffier. And then they have a little bit of rotation like the figure skater when its arms are way out. And then as that gas cloud collapses, just like the figure skater pulling their arms in, it starts to spin faster and faster. And you end up getting this kind of rotating pinwheel behavior that looks like the galaxy that was drawn earlier.
Yeah, a figure skater or a toilet flush as well.
Or a toilet flush.
All right, you have a question. What's the biggest black hole that we know about? Oh, that's a great question. I used to know the numbers for it. Do you know the numbers for it, Cameron?
The biggest one I think we know about is in the center of a nearby, well, maybe not too nearby-ish galaxy called M87, and it's about 6 billion times the mass of our sun. It's really big. It's really massive.
Yeah, thank you. I'm so glad to have backup. Okay, yeah, with the hoodie. What gave me the idea to write this book? That's a great question. Yeah. So I wanted to write a book about science and science topics for kids who weren't normally interested in science, who didn't think that they would like science. And so I wanted to write something that would maybe show them how awesome science is and how awesome things are to learn, how many awesome things there are to learn about the universe. So that's what's my main inspiration. Now, the idea for the book came when the real Oliver one day came home and he said, "Dad, Mom, I want to be an astrophysicist when I grow up," because this amazing and awesome professor called Dr. Howard came to my class and he talked to us about gamma rays. And he said, "I want to be an astrophysicist." And before I forget, I should note that the real Dr. Howard is right here, sitting in the middle. Yeah, a big round of applause. Yeah, so it's all because of him, actually. So he inspired Oliver, Oliver inspired me, and that's why we're all here today. Okay, Natalia, one more question. Yes.
Well, why can't a black hole not be a pink hole or a purple hole or a red hole?
That's a great question. Why can a black hole be a different color? Why does it have to be black? Well, actually, black holes are a little reddish, kind of, right? They're actually a little bit reddish. But the reason they're black is that black is what we see when no light comes to our eyes. Like if you close your eyes, that's why you see black, because there's no light coming into your eyes. Now, a black hole looks black because no light can come out of the black hole. It's like a hole, so light can't come out of it. Any light that hits it, it's just going to get sucked in. And so when you look at a black hole, your eyes doesn't see anything. And so your eyes think, your brain goes, "Oh, that's a black hole." That's why. But it is a little bit reddish because any light that does come out gets stretched out and makes it look kind of reddish. Yeah? Okay. All right. Okay, one question here.
What's your favorite comic that you've made?
What's my favorite comic that I've read or that I made? What's my favorite comic that I've ever made? Oh boy, it's like you're asking me to choose between my two kids. Whew. Who thinks I should say Eleanor? Who thinks I should say Oliver? They're both my favorite, of course. Yeah, I think the comics I've made about Oliver, about Eleanor are the ones that and PhD comics, which are sort of about my spouse, Sulika, are also my favorite. Great question, thank you. What do you think? All right, we have plenty of time. All right, what more questions? Is there a white hole? Like instead of a black hole, you have a white hole. I know it sounds painful. The thing is, nobody knows if there are things called white holes, but some scientists think that maybe if you go inside of a black hole and you get to the center of a black hole, it takes you inside of a wormhole tunnel, which is like a tunnel in space. And they think that maybe, just maybe, you go into the wormhole and you come out in another part of the universe into something called a white hole, which is the opposite of a black hole. So unlike a black hole sucks everything in, that's why it looks black. A white hole is just something where all that stuff basically comes out. And so that's what people think might happen in the universe, but nobody has ever seen one, and nobody's sure about that. Yeah. Would that be teleportation? Ooh. So you can get to school faster, right? No. You don't want to get to school faster? Get out of school faster. It's a one-way teleportation. Yes. Would that be teleportation? I think it depends on what you mean by teleportation. Some people might call going into a wormhole and appearing in somewhere else in the universe. They might call that teleportation. Some people might think, oh no, I want teleportation to be that I disappear and I appear somewhere else. So it kind of depends on what you call teleportation. But it would be a good way to travel through the universe really fast if you can find a wormhole that connects to points in space. You might be able to maybe send information and talk to your alien friends in another part of the universe. That would be pretty cool. Yes. Yeah, great question. I think your question is, if a black hole is a hole, and in the center of it is a wormhole that maybe takes you to another part of the space, how does it come out? How does this tunnel come out? What's going on? If nothing can come out of the black hole, where does this tunnel go? Or how does this tunnel get out of it? Is that your question, right? And assuming you survive going into the black hole. Well, first of all, nobody actually knows what's inside of a black hole. Nobody has ever been inside of a black hole. Yeah, it wouldn't be a pleasant trip. And so, but it's really weird to think about wormholes. I'm not sure anyone really understands them. They're kind of theoretical. They're people. That's what people think might happen. But they basically kind of connect points in space without actually. They're kind of like shortcuts in space. So it really is kind of like teleportation, basically. That's the answer. It's really just teleportation. You go to the center of a black hole, and then you appear in another point in space. That's pretty much it, right? Right? Astrophysicist, can I? Yeah, there you go. Thank you. Olivia, yes. Can anyone survive the black hole? Or anything in general survive a black hole? That's an awesome question. So when I said that if you get near a black hole, you get kind of shredded apart, that's because the gravity is so strong that if you were falling feet first into the black hole, the gravity on your feet was much stronger than the gravity in your head, and so the black hole would basically stretch you like spaghetti. That's called the spaghettification. It's a real scientific term. Spaghettification, a point of a black hole. Now, there are black holes that are so big that the gravity isn't as crazy. So it is technically possible to go inside of a black hole, still alive and still survive, because it would be so big that the spaghettification point happens inside of the black hole, so you can go into the black hole. But the thing is that you can go in, and you would never be able to tell anyone that you went in, because you can't turn around and shout out, "Hey, I'm inside," You can't even call them on your cell phone or your Apple Watch because the radio signals from your phone wouldn't be able to get out. So you could go in and survive, and you would be maybe the first person to ever see what's inside of a black hole, but you wouldn't be able to tell anyone, basically. You can't know. Once you go in, you can't get out. Can you have a really big rope? Oh, yeah, interesting. Like, can you lower yourself into a black hole and then pull yourself out? That's I'm sure you've gotten this one before, Cameron. How do you answer that?
Wait, sorry, I got distracted. The question was, if you lower yourself in, can you pull yourself back out?
Mm-hmm.
No, because there's so much force that's pulled on that rope as you go in that it would tear the molecules of the rope apart and prevent you. There isn't a strong enough force to be able to provide enough tension to support as you fall in, as you drop yourself in.
There's no strong enough material that we know about, or theoretically?
Well, certainly that we know about. Let me think about this. No, I don't think there's anything that could, like even theoretical adamantium or something like that would be unable to sustain.
Right. Yeah. Because I guess even like the force particles wouldn't work. Right. Right. Yes. All right. You have a question. What if you squished yourself with a rock and then went into the black hole? Well, it would be bad news from the beginning. You'd be squished. You'd be squished. And then even more squished when you go into the black hole. Oh, I see what you mean. Like pre-squish yourself so that when you get stretched out. Yeah, that's an interesting question. Interesting. Yeah. I think you would be able to survive more going into the black hole, but eventually, as you go deeper into the black hole, then it would just finish stretching you out. All right. Well, I'm happy to answer more questions. I'm going to be outside signing books. If anyone wants to get a book, I'll happily sign and doodle. Thank you so much again to Cameron, Dr. Howard, Dr. Tissot for organizing this.
Thank you. Thank you, Jorge.